Greetings, class, and welcome to Operations Management course, your 7th week. Today we'll be discussing short-term scheduling. Short-term scheduling is the objective of scheduling to allocate and prioritize demand generated by either forecast or customer order. And this is to various available facilities. The importance of short-term scheduling is that it is effective and efficient scheduling, which can lead to a competitive advantage. The faster movement of goods through the facility means better use of assets and lower costs. To put this into perspective, though, the faster you move the goods through the facility does not necessarily mean that you're going to be using better use of assets and lower costs just in itself. You have to employ them in the appropriate sequence and appropriate fashion. So I don't want you getting confused that just moving goods and services through the facility, meaning that everything's going to be great. You have to do it appropriately and you have to do it right. Additionally, capacity, when you do additional capacity on this, it results from faster throughputs. So when you do things faster, efficiently, and effectively, it will allow you to have additional capacity resulting from faster throughput, improving your customer service through faster delivery. Goods and schedules result in more dependable delivery. So the premise of this is that if you don't schedule events to occur, you're probably going to end up being inefficient in itself. So it's very understandable that scheduling is an important aspect of operations management. In fact, we live with it. Everything we do, we have a schedule on it. Some of the scheduling decisions, and what I'm going to do is I'm going to give you some examples of organizations, and of course, what the manager schedules would be like for those, or what they do. For example, in an airline, there would be schedules for maintenance of aircrafts, departure timetables, flight crews, catering, gates, ticketing, personnel, etc. In hospitals, there'd be operating room use, patient admissions, nursing, security, maintenance of staff, outpatient treatment. You can see that at least in these two areas, scheduling is important, especially with the personnel. You want to have the right people in the right location with the right equipment at the right time. Now, in a university setting, you have classroom scheduling that takes place. You have audiovisual equipment that have to be programmed into each one of the classroom events, student and instructor schedules to make sure that they match. It would be embarrassing to have a class and all of a sudden you have the wrong instructor in the class. Graduate and undergraduate courses are scheduled in such fashions. Another one would be, like, say, a production company like a Lockheed Martin factory. Well, the production of goods have to be scheduled. Purchase of materials have to be straightened out and ensured, and workers have to be scheduled for that. Now, there's some scheduling issues. Scheduling deals with the timing of operations, hence why we have a schedule. The task, though, is the allocation and prioritization of demand, because human resources and products are not necessarily always in robust amounts. So you have to schedule them in appropriate sequence for efficient use. Significant factors include forward or backward scheduling, which we will go over in a few minutes, finite or infinite loading, and the criteria for sequencing jobs. As promised, let's go talk about now forward and backward scheduling. Let's look at forward scheduling. Forward scheduling starts as soon as the requirement is known. So you have to produce something, you have to know how many are going to be produced, and you may even know the time necessary for all the production to be completed by. It produces a feasible schedule through it may not meet due dates, but you try, obviously. Frequent results in buildup of work in process inventory. Between the now and the due date, there may be a lot of work in process inventory in there because of these unscheduled failures or unscheduled events that occur in between the processing of the product. Now, backward scheduling means the due date and the schedules of the final operations come first. So you understand the due date. The schedule is then produced by working backwards through this process. Resources may not be available to accomplish the schedule. Often these approaches are combined, the forward and backwards are combined to develop a trade-off between capacity constraints and customer expectations. We identified finite and infinite loading. In finite and infinite loading, assigning jobs to workstation is a key component. When you look at finite loading, we assign work up to the capacity of the workstation. All the work gets done. Due dates may be pushed out, but all the work gets done. Infinite loading does not consider capacity. All due dates are met. Capacities may have to be adjusted. Right? When we look at scheduling, we have some criteria that we have to pay attention to. We want to always try to minimize completion time. We want to maximize utilization of facilities. We want to minimize work in process inventory, also known as WIP inventory. We want to minimize customer waiting time. That would be a benefit if we reduce the customer waiting time, would you not think? When we look at different processes and different approaches to all of this, now we suggest some approaches to scheduling. For example, if we're a process-focused facility, also known as job shops, scheduling to the customer's orders where changes in both volume and variety of jobs and client patients are frequent. Schedules are often due date focused, with loading refined by finite loading techniques. Some examples include foundries, machine shops, cabinet shops, some print shops, and many restaurants in itself, and of course, we can also consider the fashion industry here. Now, repetitive facilities, such as assembly lines, these schedule module production and product assembly based on frequent forecasts. There is finite loading with a focus on generating a forward-looking schedule. Just-in-time or JIT techniques are used to schedule components that feed the assembly line. Examples include assembly lines for washing machines, such as Whirlpool, and automobiles. Now, since Mr. Ford was the one that started the assembly line, let's go ahead and label Ford Motor Corporation as part of an example. But it could be any of the automotive industries. The same thing with motorcycle industries, anything that has repetitive facilities. When we look at product-focused facilities, which means continuous, we schedule high-volume finished products of limited variety to meet a reasonably stable demand within the existing fixed capacity. Finite loading with a focus on generating a forward-looking schedule that can meet known setup and run times for the limited range of products is important. Example, huge paper machines at, let's say, a major paper company. Beer and brewery, since I'm in South Florida, and you're probably in South Florida by taking this course, it could be Anheuser-Busch, which is located in Tampa. Potato chips like Frito-Lay's. Right? Those are product-focused facilities. Let's take a peek at scheduling process-focused facilities, since we just got through mentioning them. These are high variety, but low volume. Production items differ considerably. Schedule incoming orders without violating capacity constraints, and scheduling can be complex. Loading jobs is basically assigning jobs so that the costs, the idle time, or the completion time are minimized. Now there's two forms of these. There's capacity oriented, and there's assigning specific jobs to work centers. When we look at input and output controls, we identify overloading and underloading conditions. Now, at this point, I'd like to remind you that it is important that during this video that you have already read the chapter involved. In this case, this will be chapter 15. And it's important to do that so you understand what we're talking about. I'm giving you a brief overview of what this is about. It is your responsibility to review the chapter prior to viewing the video. Now, the video will help you. All right. Afraid not. So, but I do want you to be fully aware that it's important that you review your textbook. In this case, chapter 15. Now, again, we identify overloading and underloading conditions in input-output controls. To give you an example of input-output and how important this is, input-output is also known as I/O. If you're into the world of computers or computer dynamics, I/O would be a very important thing to you. Why? Because in computer world, you automatically know that there's a thing called RAM, random access memory, and there is memory. That's your, the regular memory that you have in your hard drive. All right? It doesn't matter how much memory you have. It is the amount and flow of information that can flow from the memory to the microprocessing chip that counts. If you're limited to 64 bits per millisecond, that's all you're going to get, is 64 bits of information per millisecond. And so your I/O is very important. The same thing with all production capacities. I/O is critical because that could be your bottleneck. See, the terminology kind of starts fitting now. Now, input-output controls prompt managerial action to resolve scheduling problems and can be maintained using a concept known as conwhip cards that control the scheduling of batches. Some examples, or an example of this input-output control includes some of the options available to operations personnel, which include the correction of performances. This is not just personnel. This is equipment and machinery. Personnel, we can always retrain, we can coach, we can mentor. The machinery, on the other hand, some machineries are very, very sensitive and require that in every series of batch, or every batch, that it be recalibrated because it has to be almost to perfection. So correcting performances is an important aspect of this. Increasing capacity is another good option to do. And increasing or reducing input to the work center is a third. Now, most of us that are in operations management know what a Gantt chart is. And it's exactly what it is. It's a Gantt. Most of you may know already because you've read the chapter, or you've already experienced this in your work environment or studied in your bachelor's degree in business. Gantt charts are important in the sense that they are schedules, but they are in-depth synchronized schedules. These load chart shows the loading and idle times of departments, machines, or facilities. In other words, the start time and the end time of each event action, or start time, end time, and sequencing start time, end time moving forward for each event. It displays relative workloads over a period of time. Schedule charts monitor jobs in the process. All Gantt charts need to be updated on a continuous and frequently basis to account for changes. Why? Because there will be changes. Process is always fluid. Customers will want to have change orders. There's going to be some delays that push the schedule around a little bit, and you have to go ahead and you have to frequently go back, monitor, and adapt your Gantt chart to be correct. Now, Gantt charts can be produced in Excel. You can also buy, or you can, if your company can go ahead and have a operations management software system. And many companies just use Microsoft Microsoft flow charts, etc. And of course, there are Gantt charts that Microsoft will sell to you in a process like operations process flow charts. Gantt charts are usually have jobs or events on the left-hand side, and then hours, days, weeks, the time flow on the top portion going from left to right, and that's your x-axis. And then it'll show you where the beginning, the ending, the flows, and have a lot of codes that'll be taking effect. Some Gantt charts are in color, some are not in color but have different lines to symbolize certain things, etc. In other words, symbols are an inherent part of the Gantt chart. Now, Gantt charts probably are best known when you're using Microsoft projects. Right? So Microsoft projects is a robust, superior type of software for operations managers. The problem that I see with many is that they think that that just buying the software and all of it being great is wonderful. The problem is you got to input the data, and the inputting of the data takes a lot of time. First of all, you got to have the data, then you got to input it, then you got to process, you got to tweak it. You're going to find gaps, you're going to find errors, you're going to find overlaps, you're going to find all sorts of issues that you're going to have to fix, and then go back, discuss it with people. Finally, you have a Gantt chart that's working or that works, and then things happen. All right. So, and then it adapts. So your Gantt chart has to be very flexible. Microsoft allows you to do all this, but you have to understand it's not as easy as everybody thinks. You have to input the data. Now, we spoke about assignment method when we were discussing this where we started this particular section of the course. And assignment methods is a special class of linear programming. Just a simple algebraic formula. Remember, you're taking past experiences and you're bringing it forward. The only thing you have to understand in linear programming is it's not the most accurate method. It is good, it's fast, it's easy, but the more data you have moving backwards, the less reliable it is. So there's an alternative, which is where you're assigning weights. So it's a weighted linear programming approach. That's another methodology. The closer you get to real time or today, you add more weight to it. The further back you go, you add lesser and lesser weights, and then you program forward. Normally, you program forward 1, 2. I wouldn't go beyond the third, even though some people might think they can go to infinity. That's not the case. The first year is fairly accurate. Fairly. It's not totally 100%. Your second year, you're probably in the area between 1 standard deviation and possibly even 2. But your third year, you're not going into 3 standard deviations of error, and errors of errors from the mean. That's not a good thing. So you got to be careful. Now, the more data you have and the more stable your data is, like for example, if you sold, because I don't want to lead you into a false impression, if you sold 100 units a month, and you've been doing this for the past 500 months, what is the probability that you'll be selling 100 units for the next 3 years? Well, it's pretty high, right? Over 90% probability. And the only reason it's not 100 is because you may have unforeseen events occur, right? So that's what I'm trying to point out. If you have stable data points that are non-changing, that are not seasonal, that are not variables, that's great. Then the linear programming could be extremely beneficial to your organization in simple form. But most data points have variabilities. Consequently, just remember, linear programming is still a great tool to use. I use it all the time, because it's fast, it's easy. I can calculate a lot of stuff in my head, or I can use the computer, do it, and we move forward. But it's just, as long as everybody understands, it's not 100% foolproof. The objective is usually to minimize cost or time. Only one job or worker is assigned to one machine or project in this particular assignment method. You build a table of cost or time associated with particular assignments. All right? Let's just say it's a typesetter. And you go from a job, let's just call that job R34. And you have a typesetter Alfred, typesetter Bob, and typesetter Carlos. And the typesetters get paid different pay. So each one gets a different set of payments. Well, when you assign the job, you're going to create zero opportunity cost by repeatedly subtracting the lower cost from each of the rows and columns. You're going to draw the minimum number of vertical and horizontal lines necessary to cover all the zeros in the table. If the number of lines equals either the number of rows or the number of columns, then you go to the fourth step. Otherwise, you just go to step 3. And you can see this in your textbook. You subtract the smallest number not covered by a line from all the other uncovered numbers. You add the same number to any numbers at the intersection of 2 lines, and you go back to step 2. The optimal assignments are at 0 locations in the table. So select 1, draw lines through the rows and columns involved, and continue to the next assignment, and so on. By the way, this is a fairly easy way of doing things. Have I done this methodology in the past? I can honestly tell you, I've never done it. Does this mean that it's not, a usable type of a system? No, that doesn't mean that at all. There are organizations that this is the way that they would like you to do it. Why? Because it's simple. It is fairly quickly, can be achieved, and it forces you to know your system. Now, sequencing jobs. These specifies the order in which the jobs should be performed at work centers. Priority rules are used to dispatch or sequence jobs. For example, first come, first serve, right? Or the shortest processing time, the earliest due date, and longest processing time. These are rules, right, that you have to follow within these. Some performance criteria include flow time. This is the time between the release of a job to a work center until the job is finished. Now let's look at some of the things that that we would like to discuss on this. You may be asked by your supervisor to calculate the average completion time of a specific job, right? So how do you do this? Okay, the boss just asked me about average completion time. Well, it's the sum of the total flow time. What is the flow time? The time between the release of a job to a work center until the job is finished, over the number of jobs. That's the average completion time. Fairly simple. It's just it's not even algebra. It's pure division. That's it. Utilization metric is the total job of work processing time, right, over the sum of total flow time. The average number of jobs in the system is the sum of total flow time divided by the total job work processing time. And the average job lateness is the total late days divided by number of jobs. Job lateness is equal to the maximum of from yesterday, 0 flows from yesterday, plus flow time minus due date. Now let's look at some comparison of sequencing rule. No one sequencing rule excels in all the criteria. For example, SPT. These do well on minimizing flow time and number of jobs in the system, but unfortunately the SPT moves long jobs to end, which may result in dissatisfied customers. FCSS does not especially do well. It actually does poorly on any criteria, but it's perceived as fair to the customer. And by the way, first come, first serve is FCSS. All right, and then EDD minimizes maximum lateness. Now, part of operations management is dealing with ratios. We do deal with them all the time. Critical ratio, or known as CR, is an index number found by dividing the time remaining until the due date by the work time remaining on the job. Jobs with low critical ratios are scheduled ahead of jobs with higher critical ratios. Critical ratios performs well on average job lateness criteria. So critical ratio is the time remaining over the workdays remaining. Now what happens when the time remaining is less than is not less, but is more than workdays remaining? If the amount of time over the amount of days is greater, you have a problem. Right? You can't perform the job. Time remaining is due date minus today's date. And then the work days remaining is work which is the lead time remaining. Why? Because if you have to produce, the time remaining is less than the amount of work days that you need, all right, then the work days remaining, you're off. Continue with the critical ratio. Let's just say that today there are currently, this is day, for an example purposes, let's say it's day 25, and you have 3 jobs A, B, and C. And the due dates for job A is 30, for B is 28, and for C is 27. The work days remaining that you have are 4, 5, and 2, respectively. To calculate the critical ratio for each one, A, B, C job, you take the first, let's say for A, the due date, which is 30 minus 25, all right? So you have 25 divided by 4. Why 4? Because that's how many days you have, work days you have remaining. Now, some of you are going to be asking, where do you get this 25 from? It's the current day. All right. So usually when we give you these things, you have all the numbers that you need. Let's do job B, for example. Very simple. Job B review. Remember the due date was 28. Remember current day is 25. Work days is 5. So you take 28 minus 25, you divide it by number of work days, and you have 5. And that'll give you 0.6. And then the third job, or job C, that is say, we know that the due date is 27. Current day is 25. Subtract those, divided by 2, you get 1. But that we don't stop there. We have to prioritize the order. So remember the rules. The greater the ratio, all right, the lower the priority. Now, the lower the ratio, the higher the priority. So job B, which had a critical ratio of 0.6, has a priority order of 1. Then, of course, followed by C, and finally A. Critical ratio techniques include determining the status of specific job, establish relative priorities among jobs on a common basis, adjust priorities automatically for changes in both demand and job progress, dynamically track job progress. Now, there's another concept that we look at, which is called sequencing end jobs on 2 machines. This is known as Johnson's rule. It works with 2 or more jobs that pass through the same 2 machines or work centers. It minimizes local production time, idle time. The formula for this will be the N, number of jobs, divided by 2, because you have 2 machines, right? Or 2 workstations. So let's look at some of Johnson's rules. The first rule is you list all jobs and times for each work center. The second, select the job with the shortest activity time if that time is in the first work center. You schedule the job first. If it's in the second work center, schedule the job last. So break ties arbitrarily. All right. Once a job is scheduled, it is eliminated from the list. You repeat these steps, 2 and 3, working the center on the sequence. Now let's look at dispatching systems, in which are rule-based. Scheduling is dynamic, and rules need to be revised to adjust the changes that are happening. Rules do not look upstream or downstream, and rules do not look beyond due dates. When we're looking at finite capacity schedule, what are some of the key factors here? Well, it overcomes disadvantages of rule-based systems by providing an interactive computer-based graphical system. Include an expert system or simulation to allow real-time response to system changes. FCS, also known as finite capacity scheduling, allows the balancing of delivery needs and efficiency. So let us look at the interactive finite capacity schedule. Obviously, the first thing you have is your planning data, which we spoke about previously already in various classes before. You have your master schedule, you have your BOM or bill of materials, and you have your inventory. Those are fed into the interactive finite capacity schedule, along with routing files, work center information, tooling and other information, priority rules, expert systems and simulation models that you've developed, setups and runtime, etc. You put all those together and it feeds into the interactive finite capacity system, looking much like a Gantt chart. These scheduling services include services systems that differ from various manufacturing. And I'm going to give you some manufacturing examples, and I'm going to give you some services. Manufacturing is schedule machines and materials. For services wise, it's just schedule staff. In manufacturing, you schedule inventories, used to smooth demand. In services, seldom you maintain inventory. For machines, in manufacturing, machine intensive and demand may be smooth. In services, labor intensive and demand may be variable, and so on and so on. But at the end, few social or behavioral issues are found in manufacturing, while in services, social and behavioral issues quite an important aspect. It's a way of life. For example, hospitals have complex scheduling systems to handle complex processes and material requirements. Banks use a cross-trained and flexible workforce and part-time workers. Retail stores use scheduling optimization systems tracking the sales, transactions, customer traffic to create work schedules in less time and with improved customer satisfaction. The airlines must meet complex FAA, Federal Aviation Administration, and union regulations, and often use linear programming to develop optimal schedules. Remember, linear programming only works if the data is very current, and they do. That's the reason they use linear programming, because the data is extremely current, and they know exactly how many customers they have to put in a plane. They know how many planes are available. When are they scheduled for maintenance? Are they due? When are they scheduled to leave? The flight times that they're going, and so on. So all of these are schedules that are properly set, but the data is very close to right on the spot, right there. And by right there, I mean it just happened yesterday. So they have yesterday's data today, which is great. When you look at 24/7 operations like police, fire department, emergency hotlines, and mail order business, they use flexible workers and variable schedules, often created using computerized systems. Now, some of the objectives, all right, to meeting staffing requirements with minimal number of workers is part of scheduling. But let me clear that up for a second. The issue is not necessarily optimizing the schedule to have minimum number of workers. The schedule can also be to optimize the number of personnel at any one time to solve a specific problem, like, for example, policing or firefighters, especially the paramedics. So in policing, we look at when calls for services, all right, or CFS, calls for services are at the highest. So we make sure that there is a higher number of police officers during these high peaks periods of time. So we move those police officers there. Now, do we see a constant normal flow of calls for services, generally speaking? The answer is yes. In fact, we conducted, when I was in the Miami Police Department, we conducted our usual schedule, because you have to schedule these assessments every few years. And we scheduled it, and we found that the same percent of peaks and trough was the same for 10 years ago. So it just continues being the same. Then the volume is different, but the percentages are the same. So if you have the same number of personnel and law enforcement that you had 10 years ago, you could not make, or there wouldn't be a prudent reason to make any changes other than political, right? But if you had less personnel in the past, and current state you have more personnel, but you have the same percentages, you just reallocate police officers based on percentage basis. There are a need for scheduling to be smooth and to keep personnel happy. If you have disgruntled personnel, you have lower performance issues, you have higher quantities of grievances, etc. You don't want that. Many techniques exist for simple algorithmics to complete, linear programs that are complex. These linear programs can include crime fighting or crime information systems, right, where you go ahead and look at crimes, but from a different relative matter. You can see if there's a correlation between the burglaries and drug sales in a specific neighborhood, or robberies and drug sales, or robberies and pawn shop items increasing, etc. There's also a thing called cyclical descheduling example. This could be in retail stores. Determines the staffing and requirements. Identify 2 consecutive days with the lowest total requirements and assign these as days off. Fairly simple, right? Make a new set of requirements subtracting the days worked by the first employee. Apply, the second step, which is identify 2 consecutive days with the lowest total requirements and assign these as day off, and complete and continue. You can do this on a continuous basis. Why? Because you don't know if from one month to another month, you're going to have a dynamic change in customers' wants, customers' desire to purchase, etc. With this in mind, I conclude the final recorded chat for today, and I wish you all the best. I will be seeing you next week. Have a great day.